Yeah, looks like the picture does work well here. Yeah, that's cool. So, yeah, this function has, actually I found this vulnerability using some static analysis, and it was very easy because it was found directly from the RPC call. Actually, there is some RPC, and you can find the RPC service code very easily using some tools like MIDA, and you can find this kind of vulnerability very easily, like a few years ago. Looks like the Microsoft patched a lot of RPC issues, so I'm very skeptical you can find these things now. If you can read these assemblies here, you can see that the argument here is user controllable. Actually, this function netp manage IPs connect is exposed through the RPC. So user directly control ARG0 argument, and it's going to ESI register, and it's actually used for the function for swprintf. So if you are familiar with any kind of a Stack Overflow, so swprintf doesn't do any kind of security checks. It doesn't do any kind of length check. So it will overflow EAX, the buffer EAX is pointing to. So the username, it's actually from the username variable, and it's actually from here. Username is here. And it's a kind of fixed side stack variable. So it will overflow some stack. So this was what I analyzed at first. And Microsoft released the patch, and this is what I got. So looks pretty cool, right? So the diff entry actually shows the entry that has the vulnerability right away. And it actually shows only 2 entries, and the other one has security implication score of 2. And the first one has 6, so you need to look into the first one. So you directly get into the result right away, even though there are 2. And the next example is also stack-based overflow. This is MS06070. Looks like, let me see. Oh yeah, this is still my example, yeah. If you look into the patch, this was just a SIS number, but if you look into the patch itself, it will show something like this. It's calling WCSLAN API to check the original buffer, and it's comparing the result with 101H, which was the length of the buffer, the original buffer. So it's checking the original the buffer that is supplied by the user with some constant number. So here's the signatures from this example. So you can use string length or WCSLAN or other string length check routines as a signature for stack buffer flow. So it's very easy. How about the other stack buffer flows? You might wonder the other stack buffer overflows will have same patterns. So let's see config.worm example. It's a MS08067, and config.worm exploited this vulnerability, and it looks like this. The diffing result looks like this. It shows 3 entries here, and you can see that the result, the first one has 20 here, so the others are like 1 and 0. So you might not need to look into like these 2. You just need to look into the first one. And what does it have? Yeah, it has something like this. It's a kind of mess here. So the red blocks on the left side, it's actually removed blocks. So they removed a lot of code from, probably from their source code. And the red blocks on the right side is inserted blocks. So they created a new code. So looks like they removed a lot of code and inserted new code here. So you might wonder, because it was a logic error, you might wonder you can find any kind of signatures there. Yeah, yes, it looks like so. Because the patched code is calling a lot of like a WCS LAN, and it's comparing the result with some numbers here. So you can still use CS LAN. And that's not all. Actually, it's calling some safe string API call here. Looks like it's a little bit fuzzy here. So it's a string CCH copy W API. It's what I was talking about. It's a safe string API from Microsoft. So if you look up the MSDN, it shows that this API is used for like a more safer operations. It's doing like a null termination, and it's doing like other more security related stuff. And it's basically same as string copy, but it's doing more checks. So if you find some patterns like a string safe string APIs like this, you can conclude that the code must have some kind of security-related patches inside it. So you can use all these patterns, like all the safe string APIs and other like string copy underbar S thing. You can use all these as your pattern for like catching the patterns. And also, according to like SDL, you might need to like remove all the unsafe like a legacy string related operations. So you might use these patterns as a kind of detecting the vulnerabilities. So here's another example. This one is integer overflow MS10-030 here. So it looks like it generates a lot of results here. And actually, the problem is inside the inetcom.dll, and it's used by Microsoft Outlook. And it's returning the problem. Looks like the first entry has something. So it's integer overflow, and if you look into the result here, it's calling ulong to ulong API here. So you might wonder what kind of API is this. It's 64-bit to 32-bit conversion routine, and it will convert any 64-bit routine value to 32-bit. And actually, the input for that conversion is coming from str to int, and the original data is coming from like user supplied response. So you might wonder what's the deal with the ulong to ulong. It's actually converting 64-bit input to 32-bit. And during the time, it checks the original value is greater than maximum 32-bit value. If the 64-bit value is greater than that maximum 32-bit value, it will just return error code. So in that way, you can check whether it's overflowing the integer. So you can use ulong to ulong function as the signature for integer overflow. And looks like somebody smells any kind of one exploit here. So if you go back to the list of functions here, you can see aside from that first one, there are a lot of other like a function list here that has been modified. It looks like they patched something without like telling vendors, security vendors or something like that. So here's the one that I found. The CIMAP for agent, it has a method called the resize message sequence number table, and looks like it has the same pattern here. It's calling ulong to ulong, same API. And I look up some RFC. Looks like there are some message sequence number in IMAP, and looks like the client is managing the table for the sequence numbers, and looks like if the server is returning too many entries, like more than 0x3 FFFF or something, then it will overflow the table from the client. So you need to like return a lot of data from the server. So I don't think this is very easy to exploitable, but still it's exploitable if the user just waits for all the data to be transferred, maybe. So next example is also integer flow here. So it's calling MALLOC here, and the length is actually from EAX here, and it's added by 0AH from the original value. So if original value like EDI was very big, it will overflow to like some small value, and it will create the integer overflow condition. So the fix is calling more CMP instruction here with original value. So it's checking twice. It's checking the original value is bigger than some constant number, and it's checking after the addition. So it's doing more comparison here. So you can use the number of CMP instructions. Maybe the patch might have more CMP instructions with it, and the unpatched one is not doing more sanity checks. So, and also it will come with some calls like malloc or hlog or any call that ALOC patterns inside it. So maybe you can use this as a kind of sign for integer flow. And next example is double free, and it's a workstation service, and it's actually found by Codip peers from DV Labs. And the original function was calling nappy memory free, but the patched one doesn't. So it looks like the original one was calling one more time. And the RPC is actually this function was exposed through RPC, and the operation number was 0x14, and this means that the function is exposed through RPC, and you can directly access that function. So if you pass some argument to this function, then you will create a double free condition. But the good news is that it will check access control list. It will go through access control list, so you must have some valid credentials to the system. So it's not anonymous attack or something. So looks like these informations are not like clearly reported anywhere. So you can find that details very easily, like doing the diffing, like this one. And you can create, you can deduce new signatures here. If you call free or nappy memory free or any kind of free related functions, it might indicate some double free condition. And the next example is use after free. And I found that it's calling a lot of, like what is that, replace PTR functions. And the original one was, the function was called by like a 6 code locations, and actually the patched one was calling that replace PTR API like from a lot of places related to like event. And actually it's doing some kind of pointer replacement. So looks like the original code was missing that kind of pointer replace